Hello, everyone. Thank you for joining this talk about revolutionizing platform engineering with AI agents and GraphRag. I'm Shubham, and I work in the Outshift department within Cisco. It's a innovation incubation engine that's working on things like agentic AI and quantum. And we are kind of the platform engineering team within Outshift, and we are focused on how we can leverage sort of the new cutting edge technologies to empower our developers and product teams to deploy their applications and maintain them. So uh, our developers and product teams, they usually have a lot of features and prototypes and applications that they want to deploy, in our platform. And naturally, we become kind of the bottleneck for uh, a lot of these requests. And so there's a lot of burnout, cognitive load, and we have to deal with a lot of automation and tooling and different sources of information. And so it's a lot, and it's a trend that is happening across the industry in platform engineering. So about last year this time, we were thinking how we can use AI and agentic AI to kind of uh, improve this and make our lives easier. And so we came up with CAPE. So CAPE is Community AI Platform Engineering, and it's a fully open source project, part of Canoe with collaboration with the agency. And what we wanted to tackle was sort of three sort of classes of problems. We wanted CAPE to be able to answer knowledge-based questions, like when developers will ask, "Hey, how do I do this? What pods are in my applications and whatnot." We also wanted to solve self-service problems, so that they can basically deploy applications themselves and do the maintenance on them themselves. So instead of interacting with a human to do this, they could interact with an agent. And also something that we are kind of focusing on a little bit later, which is, we wanted CAPE to also do code generation and sort of maybe generate configurations and even Terraform code. But that's something that's in the future. So when we looked at making sort of CAPE more knowledgeable, we quickly identified three sort of classes of data. So we had a lot of documentation and readmes and text that exist in our system. We also have a lot of structured data, like JSON, YAML, like AWS resources, Backstage resources, Kubernetes resources. And we also had live data like logs and like on-call schedule and whatnot, right? And so we mostly focused on the first two for the database side. So we basically created embeddings of these and created a simple RAG system. So we put all of this in a vector database and let the LLM sort of answer questions. And this worked well for questions that are like more simple, like how to do this, what is this, and if there is documentation that answers that, it would answer it quite well. But especially for structured data, where you have lots of different domains of information, it won't necessarily connect, relate. Okay, how is this entity or this information related to some other information, right? And so in this case, in the right, you can see an example of this. Like, I would say, hey, tell me about Project Bravo. It's fine. But when I say what EC2 instance or S3 buckets is it deployed in, it will confidently be incorrect and say, oh, it's not deployed anywhere. But it's because it couldn't really figure out how those two things are related, right? Also, it's very hard to figure out why things are going wrong because of the black box nature of embeddings. So we looked at, GraphRag, right? And there was a nice Neo4j blog about this. And what we did was basically build the graph, and then we would get triplets from the graph, so node, relationship node, and we would embed those triplets to allow the LLM to have an understanding of how things are related, right? And this worked decently, especially for like single hop relationships, like, hey, like this AWS account belongs to this Baxter system. But for indirect relations or where you have multi-hop relations, it still wouldn't work very well. And we still had the problem of black box nature of the embeddings. So with our attempt 2, what we tried to do was we looked at the, we decided to drop the embeddings and decided to generate the Cypher GQL queries live during the query. And so we used the Neo4j LangChain library. And what we would do is basically give the schema of the Neo4j graph as a system prompt, and let the LLM generate the Cypher query to then retrieve the right data and then answer the question. So this worked decently well. It was able to answer complex queries and generate complex, Cypher query. And it's also easier to troubleshoot. So when a developer says, "Hey, the answer it gave was incorrect," we could figure out, okay, why that's the case, right? But the issue was that there's a lot of Cypher errors and GQL errors that it would do. It would have invalid Cypher, or sometimes with wrong property names and whatnot, and then it would hallucinate. And so, and especially with big schemas, it will get confused and ignore relationship names and property names and just go haywire, right? So we kind of evolved this into the next attempt, which where we, instead of pouring the entire schema, we did two things. One is we added a React loop, a reason and act loop, and we, instead of letting the LLM generate the query right away, we gave it specific tools that are curated queries, right? So like, hey, like a tool would be get entity type properties, or a tool would be shortest path between the two types of or labels, right? And so, and we still had the raw query as a tool. And what this would mean is that the LLM would basically iterate over the queries and iterate over the question a lot more and reason about, okay, well, how do I get to that answer, right? And so, and this would mean that any errors that it would make in Cypher, invalid Cypher and whatnot, it would also, it would correct its own mistake, and the system prompt is not flooded with lots and lots of schema stuff that might not be relevant for the question. So I haven't really talked about how we generated the graph. Initially, it was manually, but we realized that's a lot of maintenance. So we wanted to automate this. And what we realized is that a lot of the relationships that we were building were basically foreign key relationships. So what we are doing is that, so we were initially wanted to give all the data to LLM, but that costs a lot of token. So what we did is basically use full text search to figure out, okay, this type of entity or this label connects with this other label, and if that happens multiple times over, we kind of shortlist that as a relationship candidate, and then give it to the LLM to evaluate and then either accept or reject the relationship and basically generate the graph, right? And there's more details about this in our blog, which came out yesterday. So feel free to go there and sort of see the details. So with that, I will quickly show a demo of all of this. So I will go to the browser, and first and foremost, I'm going to generate the graph, build the graph. So I'm going to quickly do that. That takes a little bit of time as it analyzes everything. So meanwhile, I'm going to show that, okay, I have a Neo4j which with bunch of entities, bunch of documents, and you can see there's a couple of AWS accounts and like all dummy data basically, but they don't really have any relations, right? They're just entities in a database. We also have another graph with the schema. And so we would, and the idea is that the agent would basically evaluate this and create the graph. And so once it does that, we'll be able to see the different relations being created. So we'll give it a little bit of time and see. Let's see. So it should be done fairly quickly. It's not a lot. It's not a big graph just for the demo purposes, but it should be able to figure out the different relationships. So, and this is our UI, by the way, for the RAG system. And yeah, so yeah, now it should have created that. Yeah, so we see that we have a nice graph schema. And if I go into the Neo4j, and if I click, yeah, there's relationships now, right? So that's how we basically build the graph, is by using foreign key relationships and sort of making the LLM evaluate them. So now on the other side, we will basically try to query relations. So I'll ask like, tell me more about project Bravo, and this is a fairly simple question, so you should be able to find some information about that. Yeah, I can ask like what S3 buckets are are linked to it, and also give me the AWS accounts for that those S3 buckets. So now this is a multi-hop relationship, and it should be iteratively querying the graph to figure out, okay, what's happening. So you can see, for example, that we had a project Bravo bucket, and this is the account ID. I can also have a few other queries I can try. So for example, this is something a little bit more complex where, hey, I have this service, I want to find out which namespace cluster and which account it belongs to, and this will kind of leverage the multi-hop relationships between in the graph, right? And so hopefully, again, the LLM will iteratively query the graph, figure out what the properties are, what the relationships are, what the labels are, and it will refine the query as needed. And yeah, it's a bit of a complex query, so hopefully it will find something. Yeah, it's able to figure out that, hey, here's different clusters and accounts, and also differences on that. So with that, it's a simple demo. All of the stuff I've shown is all open source. You can deploy it in your laptop, play around with it, try it out. And if you like the project, please do support us, give us a star, join the community. It's built by platform engineers for platform engineers. So and the Neo4j is an amazing technology that we are using. So yeah, with that, thank you.